let's take a look at this piecewise function that I drew here. I want you to, in your groups, come up with a formula for this piecewise function, f of x. So I'll just remind you, the notation for writing a piecewise function is like this. And then you put a big curly bracket, and you put your various formulas in there, and then it would say if, and then you put the restrictions on x. Okay, so I have two pieces of this graph, so that means I'm going to have two different formulas. So this first piece, from here to here, what's the equation of that line? No. 2. Y equals 2. Every point on that line has a y coordinate of 2, so its formula is just y equals 2. And I use that formula for what values of x? -4 to 0. So -4 less than or equal to x less than or equal to 0, because the dots are closed. All right, and then the second piece of my graph going from here to here, what's the equation of that line? No. 2 minus x. Yep, my y-intercept is a 2, and my slope is -1. Yes. Thinking that it would be 0 less than or equal to x less than or equal to -4. So the alligator always has to eat the larger thing. So if you wrote this, you've written that 0 is less than -4, which isn't true, right? Because the alligator is eating the -4. So you always go left to right, smallest to biggest. Okay, so then the equation of this green line would, if we use y equals mx plus b, the slope is 1, -1, and the y-intercept is 2. So this would be -x plus 2. And what x values does that piece of the line cover? 0 to 4. So I'll put 0, x, 4. And I'm not putting an or equal to on the 0 because I put an or equal to on the 0 here, even though they both give you the same thing. Technically, there'd be nothing wrong with adding the 4 equal to there, but it's just kind of bad form. So you really only want to include it in one place, and you can include it in either one. It doesn't matter. You could leave this one just a less than and put the or equal to here, but you're really only supposed to put it in one spot. Yes. Well, because see here how it's 0. I can either plug the 0 into y equals 2, or I can plug the 0 into the -x plus 2, and it's going to give me the same result. Does that make sense? So it's like the two pieces of my graph share that point. So I could put an or equal to in both places, you know, here and here. There's technically nothing wrong with that, but it's just like bad form mathematically. It's like convention. So you just choose which one to take away. Yeah. So you could get rid of that one or get rid of the other one, and it doesn't matter. You just only put it on one. So any questions on how we came up with the equations? Okay. So again, looking at the graph, what's the domain of this function? Yep, -4 to 4. Those are the x values that are covered by this function. -4 to 4. Good. And then how about the range? -2 to 2. Those are the y values covered by the function. Good. All right, so using the graph, I want you to fill in this table of values for f of x. Take a couple of minutes to do that now. All right, so I can either use the formula we wrote or the graph to fill in this table of values. So I'm just going to rewrite the formula here because I saw some people doing it this way. Okay, so when x is -4, I'll do it with the graph first. So I find -4 on the graph, go up, find the point on the graph that has an x coordinate of -4, and what's its y coordinate? 2. If I wanted to do it using my formulas, I would say, okay, well, -4 falls into this interval, so my output should be 2. What about -3? What's my y value when x is -3? 2. And it's 2 until I get to 0. And then at 1, what's my y value? 1. Yeah, so I can do it on the graph. I can find an x value of 1, go up to the graph, get the y value is also 1. Or I can look at my formula, and I can say, well, 1 falls into this interval for x. So if I plug a 1 in for x, I get -1 plus 2, which is 1. All right, so what's my y value when x is 2? 0. How about when x is 3? -1. And when x is 4? -2. Okay, so we have this table of values for f now. And the table of values and the graph both have all that same information. It's just a different way of presenting it. So what we're going to do is we're going to start to consider various relatives of this little piecewise function that we have here. Our first relative is going to be f of x plus 2. So I want to create a table of values and a graph for this relative. So when x is -4, f of x plus 2 means just evaluate f of -4 and then add 2 to it. Okay, so I'm going to do f of -4 and add 2. Now what is f of -4? 2. So this is going to be 2 plus 2, which is 4. Okay. Now I'm going to do the same thing for -3. I'm going to plug -3 into f, so I'm going to do f of -3, and then I'm going to add 2. Now what is f of -3? 2. So I'm going to do 2 plus 2, and I get 4 again. So for when x is -2, I'm going to plug -2 into f. So I'm going to do f of -2, and then I'm going to add 2. F of -2 is 2. Add 2 more, and I get 4. So I'm going to keep getting 4 until 0. These are going to look the same. And then when I plug in 1, I'm going to get something a little bit different. So now instead of doing, okay, so I have f of x plus 2. I'm going to replace the x with a 1. So I have f of 1 plus 2. And now what is f of 1? 1. So this is going to be 1 plus 2, which is 3. And then I'm going to do f of 2 plus 2. What is f of 2? 0. So 0 plus 2 is 2. And then f of 3 plus 2. And what is f of 3? -1 plus 2 is 1. And f of 4 plus 2, which is -2 plus 2, which is 0. So now I'm going to plot these points where I'm going to use, this is my x, these are my x's, And these are my y's, my outputs. Okay, so I'm going to have -4, 4, and then -3, 4, -2, 4, -1, 4, and 0, 4. And then I have 1, 3, 2, 2, 3, 1, and 4, 0. So if I connect them, I get that green graph there. So how can you explain the relationship between the graph of f of x, this black line, and the graph of f of x plus 2, the relative we just graphed to the green line? Okay, that is, how can I transform the graph of f into the graph of f of x plus 2? Yeah, we moved the whole thing up 2. We shift f of x up 2 units to get f of x plus 2. Mm-hmm. Right here. So I had to plug -2 into f first, and then the output of that is what I added 2 to. So f of -2, so if I look at this black line here, right? F of -2 means find an x value of -2, give the y value, which is +2. So f of -2 equals 2. So I replaced that f of -2 with a 2, because those are equal. Yes. Yes. Or you can refer back to this table. That's why I had you make this whole table first. Yeah. Okay, so in general, how do you think the graph of f of x plus some number is related to the graph of f of x? Yeah. See? Yes. We shift f of x vertically by k units. I should say by k units to get f of x plus k. What if k is negative? You shift down. Yeah, great. So here's a graph of x squared. I want you to draw a graph of g of x minus 3, right? So that would be x squared minus 3. Without using your graphing calculator, I want you to just do an appropriate shift of this graph. And you can use the table as an aid if you want, but you don't have to. So basically, I have g of x minus 3, or x squared minus 3. I'm going to take the graph of x squared and shift it how? Down 3. So I'm going to look at some key points here. This point right here, going to go down 3 to right here. And then I have the point 1, 1. I'm going to shift it down by 3. 1, 2, 3, and it lands here. And this point, -1, 1, go down 3. And then I've got 2, 4. I could bring that down 3. And -2, 4, bring that down 3. And then you can just connect the dots. And if you needed to, we could have used some points in the table, right? So -1, or let's just do a few. We'll do -4. I would do g of -4 minus 3. What is g of -4? You don't know, is that what you're saying, Julie? So what is the function g? What is g of x equal to? X squared. So g of x is x squared. So g of -4 would be -4 squared. So it's 16 minus 3 is 13. And then when x is -3, I would do g of -3 minus 3, 6. Yep. And then g of -2 minus 3 would be 1. And I actually graphed that one. I graphed -2, 1 right here. So you don't have to graph every single point, just enough to see what happens to the graph. And you would say, oh, they're all going down 3. So any questions so far? Okay. So our next relative is f of x plus 1. Now, what is different here than the last relative? It's all in parentheses. Instead of doing f of x first and then adding on or subtracting, I'm going to add or subtract on the x and then evaluate. So f of x plus 1, when x is 6, would be f of -6 plus 1. So you add to the x first, then evaluate. So what is -6 plus 1? -5. So I need to know f of -5 here. So to evaluate f of -5, I go to my graph of f. And what is the y value when x is -5? There isn't one, right? Here I find -5, and oh, I have no graph here. So this is undefined. So I don't actually have a value there. Okay, now if I try to plug in a -5, I get f of -5 plus 1, which is f of what? -4. And f of -4 is 2. We get that from the graph. When x is -4, on the graph, the y coordinate is 2. Okay, so now I'm going to go through and do this for the rest of the table. So this is going to be f of -4 plus 1, which is f of -3. And what's f of -3? 2. F of -3 plus 1, which is f of -2. And f of -2 is 2. F of -2 plus 1 is f of -1. F of -1 is 2. F of -1 plus 1, that's f of 0, which is 2. Okay. Now I'm going to do f of 0 plus 1, which is f of 1. And what's f of 1? 1. According to my graph, you find the point on the graph that has an x coordinate of 1 and give its y coordinate, which is also 1. So then I'm going to do f of 1 plus 1, which is f of 2. And what's f of 2? 0. F of 2 plus 1 is f of 3. And what's f of 3? -1. And f of 3 plus 1, which is f of 4, which is -2. F of 4 plus 1 is f of 5. And there is no f of 5. Function is only defined from -4 to 4. All right, so now I'm going to plot my points. These are my x's. These are my y's. I'm going to go through and plot them. So let's see, -5, 2, -4, 2, -3, 2, -2, 2, -1, 2, 0, 1, 1, 0, oops, 1, 0, 2, -1, 3, -2, and 4 was undefined. I couldn't plug in a 4. So those are all my points. Connect them. And how can I describe the transformation from f of x to the blue graph, which is f of x plus 1? It shifted left 1. Yeah. I shifted f of x left 1 unit to get f of x plus 1. That surprise anybody? What would you have expected to have happen? What? To shift right 1? Yeah, because positive you think would go right, right? Why did it go left? Go back to the table, right? Because I'm going to add 1 to x before I apply f to it, I can go 1 unit further to the left. Like I used to only be able to plug in -4. That was the smallest thing I could plug into f. If I get to add 1 to x before I plug it in, now I can go to -5. Now I can plug -5 in and still get an output. And I used to be able to go all the way to 4. When I plugged into f, I could plug in all the way to 4. But if I'm going to add 1 to the x value before I plug into f, I can no longer plug 4 in. I have to stop at 3. So in general, what do you think the result is if you want to graph f of x plus k with x plus k in parentheses? Yeah, so we shift f of x horizontally by k units. And I'm going to put a little clarification here that says if k is positive, you shift left. What do you think, which is what happened before, right? I had a positive k, a plus 1. What do you think would happen if k was negative? It's going to shift right. K is negative, shift right. So I want you to try. Here's a graph of x cubed. I want you to sketch a graph of h of x minus 2. That is x minus 2 cubed. Okay. I want you to sketch a graph of it. You can use the table if you want, but you don't have to. Okay, so what's the transformation? How would I transform x cubed into x minus 2 cubed? Move it to the right 2 units. So I'm just going to pick a few key points, right? Like maybe this one, move that right 2 places, and it lands there. And then maybe 1, 1. Oops. 1, 1. I'm going to shift that right 2 places, and it'll land here. And then I could look at this -1, -1. Shift that 2 to the right, and it lands here. And then you could pick any more points if you want, but we're just going to copy the whole graph like that. Not very good, but we get the idea. So the whole graph moved right 2. And if you want, you can do a few points, right? So let's say I want to do -2. Now let's do 2. So if I want to see the value of y when x is 2, I have to plug 2 into here. So this would be h of 2 minus 2, which is h of 0. And since h of x is x cubed, h of 0 is 0 cubed, or 0. So my x coordinate is 2, y coordinate is 0, and that is one of the points that I put on the graph, 2, 0. So you can use the table of values to help you if you ever forget the rules. You know, you can always make tables of values to remind you what's happening. But you don't have to. Once you know that, you know, subtracting inside the parentheses means shift right, you can just jump right to that. Okay, so our next relative is negative of f of x. So why don't you try these next two in your groups. See if you can figure out what the transformation is for f of negative x and negative f of x. All right, let me just get, there's a group, so some people are having a little trouble getting started, so just to get you off on the right foot here. We want to take negative f of x. So x is negative 4, so I'm just going to do negative f of negative 4. Just replace the x with a negative 4. F of negative 4 is 2, so this is negative 2, because you're taking the opposite of 2. And then we're going to take negative f of negative 3, which again would be negative 2. So that's how you start that one. For this one, you're going to take f of the opposite of x. So instead of negative 4, we're going to take f of positive 4, which is negative 2. And then instead of f of negative 3, you take f of positive 3, which is negative 1. So you keep going like that for that one. Okay, so let's finish doing these together. Working on negative f of x. So when x is negative 2, we're going to do negative f of negative 2. Just plug in the x that you're given, get the result, and take the opposite. So when I plug in a negative 2, the output is positive 2, but then I have to take the opposite of it, so I get negative 2. And negative f of negative 1. Well, f of negative 1 is 2, so I have to take the negative of that, negative 2. Negative f of 0. F of 0 is 2, and I have an opposite sign out front, so it's going to be negative 2. And I have to take negative f of 1. Well, f of 1 is what? 1. So I have to take the opposite of that. So I get opposite of 1. And then negative f of 2. And f of 2 is 0. What's the opposite of 0? 0. And then negative f of 3. F of 3 is negative 1. What's the opposite of negative 1? 1. And then negative f of 4. F of 4 is negative 2. What's the opposite of negative 2? 2. Okay, so those are all my values. These are my x's. These are my y's. And I plot them. So I'm going to get negative 4, negative 2, negative 3, negative 2, up to 0, negative 2. And then I get 1, negative 1, 2, 0, 3, 1, and 4, 2. Connect the dots. And how would you describe the transformation? How did I change f of x into negative f of x? Flipped it. I flipped it over the x-axis. Flipped f of x over the x-axis to get negative f of x. All right, so let's look at the next one, f of negative x. If we did the first couple, so I'm going to take f of the opposite of x. So whatever x they gave me, I'm going to plug in the opposite value into f. So if they gave me a negative 2 for x, I'm going to take f of positive 2. And what's f of 2? 0. Then I'm going to take f of positive 1, and that is 1. And then f of, well, the opposite of 0 is still 0. And f of 0 is 2. Okay, then instead of taking f of 1, they gave me x is 1. I'm going to take f of the opposite of 1, f of negative 1, which is 2. And all these last ones are just going to keep coming out as 2. So then if I plot them, I have negative 4, negative 2, negative 3, negative 1, negative 2, 0, negative 1, 1, 0, 2, 1, 2, 2, 2, 3, 2, 4, 2. And connect them. And I end up with that graph that's blue. Okay, I was plotting, these are my x's, these are my y's. So how would you describe the transformation from f of x to f of negative x? What happened? Yeah, flipped over the y-axis. So reflection over the y-axis. Flipped f of x over the y-axis. To get f of negative x. Okay, so now that you know the rules about how to transform when negatives come into the equation, I want you to sketch graphs of negative j of x, which is negative square root x, and j of negative x, which is the square root of negative x. I gave you a table. You can use it if you want, or you can just go right to the sketch. All right, so negative j of x, when I look at this one, this should be a reflection over the x-axis, right? We said when you throw a negative out front, you reflect over the x-axis. So negative j of x would look like, reflect this thing over the x-axis, something like this. That was terrible. So that'd be terrible. There we go. So this one is negative j of x. Now j of negative x, what kind of reflection is that one when you put a negative inside? Over the y-axis. So I want to take this original and reflect it over the y-axis. And you get something like this. J of negative x. So this is reflect that one over the y-axis. So once you know the rules, you don't even need the tables. The tables are to help you discover the rules in the first place or rediscover them if you forgot them. Right? So you can always make a table if you're stuck. But once we went through all the work of making a table and discovering what the rule is, then you can just use the rule. Okay? And this is a little chart I made for you to try to keep track of all the rules. And you can use it on the test. You know, put a copy of it on your cheat sheet for the test. So this is all our conclusions for the different kinds of transformations. And filling out everything but what I've shaded here is going to be your only immediate homework. Okay. The very end of your packet has homework for section 2.5. But there's so much more to cover. You can probably go in and you might be able to do a few of the problems, but you might want to wait until after next class to make a really serious attempt. Okay, so, but what you should do for homework is fill out this chart of rules.